It's January. Temperatures across Europe have plunged well below freezing, and heating systems are working overtime to keep millions of homes warm. At the same time, the global gas market is stretched to its limit. U.S. sanctions have effectively blocked Russian gas exports, leaving Europe and China to bid against each other for a limited supply of Qatari liquefied natural gas. The resulting competition is pushing global prices toward the 2022 peak. This chart tracks oil and gas production in the British North Sea. Domestic extraction has crashed since its peak in the late 1990s, even though the UK still relies on gas to generate roughly 30% of its electricity. Compared to its neighbors, the UK has very little room for error. While France and the Netherlands have months of reserves built up, the UK, represented here by the orange bar, holds only about 19 days of gas storage. This combination of peak demand, a volatile global market, and a lack of physical storage creates a dangerous vulnerability. It makes the UK grid an ideal target for an adversary looking to exert massive economic pressure without crossing the threshold of open military conflict. Russian military doctrine refers to this as gibridnaya voyna, hybrid warfare. It is a strategy of deniable, disruptive operations designed to undermine national resilience while staying just below the level of open war. The first sign of an attack is a massive pressure drop in the North Sea. Deep underwater, an explosion at the Sleipner Riser processing platform ruptures a major transport pipeline, sending a plume of gas into the dark water. The impact is instantaneous. 18% of the UK's total winter gas supply vanishes from the system. Inside the National Energy System Operator, or NESO, the gridmaster attempts to rebalance the load. Usually, the system can absorb the loss of its largest single asset, but the extreme cold has already exhausted most of the available redundancies. Losing a critical pipeline while global supplies are already squeezed transforms a localized industrial incident into a national security crisis. As the gas supply falters, the adversary pivots to a secondary target. They know the grid will attempt to compensate using renewable sources, so they launch a digital strike against the wind fleet. At an offshore wind control room, a cyber sleuth watches as contact is lost with 174 turbines simultaneously. A compromised security update from the turbine manufacturer has triggered a safe shutdown. The blades come to a halt, and 1.2 gigawatts of clean power, roughly 2.5% of total demand, disappears from the grid. The digital attack spreads to legacy infrastructure as well. Malware is discovered in a peripheral system of the SCADA unit at a major gas processing terminal, the central hub for a quarter of all UK gas imports. Engineers are forced to initiate an immediate no-flow shutdown. They have to verify that the malware hasn't compromised the terminal's safety protocols before they can risk restarting the pumps. Decentralized renewables are physically harder to destroy than a single gas plant, but this event shows the trade-off. Their reliance on centralized software updates creates a single point of failure that an attacker can exploit to trigger a widespread blackout. While the digital attack unfolds, a naval commander monitors the stormy North Sea, where physical anomalies are appearing on the seabed. This map shows the dense network of undersea cables connecting the UK to the European mainland. Currently, a commercial ship is dragging its anchor through these congested corridors. Nearby, a Russian vessel is mapping this infrastructure, using military-grade lasers to blind tracking RAF pilots. To counter the threat, the naval commander deploys the Atlantic Bastion Fleet. This unit uses autonomous vessels and AI to shadow the saboteurs and prevent them from damaging the cables. The ocean floor is now a primary front line. Protecting the civilian utilities we rely on every day has become a task of active military defense. The UK is now minutes away from nationwide rolling blackouts. The gridmaster has exhausted market options, and there is no more gas left to buy. Out at sea, the Atlantic Bastion Fleet intercepts the container ship, preventing it from severing the remaining subsea power links and stabilizing connections to Europe. To bridge the remaining power gap, the government authorizes the use of long-duration energy storage sites located on Ministry of Defense land. These are strategic reserves of power co-located with military facilities. These military-grade batteries discharge directly into the failing civilian grid. It is the first time these reserves, typically held for military readiness, have been used to stabilize the national energy supply during a civilian crisis. Adapting to hybrid warfare means treating energy as a core component of national defense. By co-locating strategic storage on resilient military sites, the state can provide an emergency buffer that remains independent of global market fluctuations. Even with military batteries online, supply alone isn't enough. The final stabilization of the grid requires a response from the public. The Gridmaster issues a nationwide emergency alert to smart meters. Millions of citizens respond by immediately turning off non-essential appliances, creating a massive instantaneous drop in the total electrical load. This approach mirrors the system used in Texas by eCart. Households and industrial processes are integrated into the grid's response, automatically shifting demand to protect the system during extreme weather or supply shocks. Securing a modern energy system involves more than just building new power plants. It requires a defense that links naval fleets and cyber engineers with the coordinated participation of millions of everyday citizens.